Before we start going into lesson 413, we're going to review some of the content from previous material that we covered out. Primarily, the intro lesson deals with simplifying radicals. It deals with multiplying conjugates of imaginary numbers, and solving quadratics using the quadratic formula, and even how to use your calculator. Now, this video in particular is going to focus on the first two concepts: how to simplify radicals that involve negative numbers, and multiplying conjugates. So let's just dive into the first 7 problems. All right, so number 1 says simplify the following radical, negative 48 inside the square root. Well, the first thing we're going to do is we are going to take out the negative. And we can see over here as reminders from Algebra 2 is that I squared equals negative 1, which that means that I equals the square root of negative 1. And so if I have a negative inside of a radical, I can take that negative out and turn it into an I. So I take the negative, I can pull it out, turn it into an I, and I still have the square root of 48. Now I just simplify the radical the same way we've done it before. I'm going to take 48 and break it down into numbers that multiply to give it to me. Now I'm going to be smart with my numbers. I check the perfect squares first, because if I know a perfect square goes into this, that breaks into a pair automatically. And so I know 48 is 16 times 3. 16 breaks into 4 and 4 right away. Now here's why that's helpful, is because right here I have a pair of 4s. I have 4 times 4. And I'm going to write down long ways here. I have 4 times 4, so that's 4 squared. Now I no longer have the 16, and I no longer have the 48 because I broke those down. But I still have that 3. So my radical is really this. I have I still on the outside, square root of 4 squared times 3. Now this is where we have to realize we look for a grouping of 2 with squares because the square and the square root are going to cancel. If I say what's the square root of 4 squared, you're going to tell me the square root of 4 squared is 4. Well, then the 3 remains inside, and I still have my I. And so my final answer for this one is 4i square root of 3. If I have a pair, I don't need to break it down anymore. I can write it as it being squared, and the square root's going to cancel that out. All right, so same idea. I have square root of negative 25. Well, again, notice I have that negative. I'm going to take that negative out, and I'm going to write it as an I. So really, I have I square root of 25. Now, here, do I really need to break down square root of 25, or do I know the square root of 25 is 5? So my answer is 5i. Even if I broke it down, though, 25 is 5 squared. And so I would have the square root of 5 squared, and the square and the square root cancel each other out, and that would give me my 5i. So when it's a perfect square, we just square root it. But when we know it's not a perfect square like 48, I have to break it down into the factors. But really, there's no difference with simplifying radicals involving negative numbers, except for right in the beginning, take the negative out and turn it into an I. So I have the square root of 98 on the inside, but that negative comes out and becomes an I. So 98. Well, again, I'm going to keep trying perfect squares. I know that 98 is 49 times 2, and 49 is 7 times 7. Again, I'm going to show you why it works. It's because I can rewrite it as 7 squared times 2 inside the radical and still have that I on the outside. Well, the radical and the 7 squared, we're going to cancel each other out, and I'm just going to be left with a 7 and an I on the outside. The radical and the 2 are not going to cancel each other out, so it's going to stay on the inside. So that is that one. And the last one, it may look intimidating with square root of negative 24, but the same idea. I'm going to write it as I square root of 24 over 6. Well, the bottom is just a normal number. It's going to be over 6, not bad, but I'm going to off to the side break down the square root of 24. Again, I try perfect squares first, so I'm going to try 4. So I have 4 breaks into 2 and 2, 6 breaks into 2 and 3. Notice I have right here a pair of 2's. So that's like saying the square root of 2 squared, which is just 2. Cancels out, out, out. Alright, so I have that 2 and the 3, but nothing can be combined to those to cancel out the radical, so those are going to go back inside and be multiplied. So really, I have, at this point, a 2 on the outside, an I, a square root of 6, and a 6 on the bottom. Well, what's in the radical is protected, but this is like saying you have 2/6. So that's like saying you have 1/3. So I have I, square root of 6, over 3. And that's the final answer. So that's simplifying radicals involving negative inside the square root. You just take the negative out, make it an I, don't forget about it, and simplify the radical. Now, multiplying by conjugates is going to be a little bit different. It's still going to be distributing like we've done before, but I will have to keep in mind this rule. I squared equals -1. So let's jump into problem number 5. So here we go. I'm going to set up the area model, and I'm going to put my 4 plus I on top. This should be an I right here, so I have a 4 minus I on the bottom. After we do the first example, I'm going to refresh your memory on what is a conjugate. So let's do this. I have 4 times 4, so that's 16. I have 4 times I, that's 4I. 4 times negative I is negative 4I. Now, a positive times a negative is a negative. I times I squared. So notice what happens when I go to the next step. I'm going to try and combine things together. Well, 4I and negative 4I, it's very interesting to see that those are going to cancel each other out. So I'm really left with a 16. I have minus I squared. Well, I squared is -1. So I really have 16 plus 1, which is 17. And that's my answer. So here's what conjugates are. And you've dealt with them actually since you've been factoring. Is conjugates are the same terms, opposite operations. So I have A plus B, so the conjugate would be A minus B, or vice versa. Now in this case, conjugates with imaginary numbers are A plus BI and A minus BI. You have conjugates that involve radicals as well. It's the idea that you have the same terms, just the opposite operation between them. Now here's why, the way you've dealt with this before. This is difference of squares. I mean, think about this. A squared minus B squared factors into A plus B, A minus B. And if you look at that area model we did for number 5, you could see I really took my A, 4, I squared it. I took my B, I squared it, which gives me the -1, and I subtracted them. So your difference of squares is conjugates. Alright, so let's try this one. And we'll see what keeps happening every time I multiply an expression by its conjugate, especially, let's say, a complex expression by its conjugate. So I'm going to do -5 plus 2i on the side, and I'll do -5 minus 2i on the top. And let's see, negative times a negative is a positive. Let's see, -5 times -2i is a positive 10i. -5 and 2i is a negative 10i. Notice, I think those are going to cancel. Positive, negative is a negative, and I get 4i squared. Alright, so what do I have here? I have 25, check. Now the 10i and the negative 10i, those are going to cancel each other out. That's interesting. And I have a minus 4, and then I squared, it's -1. So really I have 25 plus 4, which is 29. So what happens when you multiply a complex number by its conjugate? It becomes real. The -5 plus 2i times -5 minus 2i, it becomes a real number. It no longer has an I. And so that's something that's nice to keep in mind. Why do we multiply if we can use it? Why do we take a complex expression like 3 plus 2i, and if we multiply by 3 minus 2i, it's going to get rid of the imaginary numbers. So I have 6i and -6i are going to cancel. And then minus and negative because really that is -4 times -1 is +4, and so I get 13. So this video went over the first 7 problems which dealt with simplifying radicals. The reason why that's there is because the next set, which deals with the quadratic formula, and then the multiplying conjugates, is where we're going to be going that direction, so we want to kind of be aware. So the next video we'll look at the quadratic formula, and then we'll do a third video on how to use your calculator.